So let's understand, right, what is an overfitting problem and how do we see this problem, right? To understand this overfitting problem, right, what I want to do is I want to give you an analogy, right, to understand this concept well. Now I want you to understand that there are three students in a class, okay, right? And this student is name is A, this student name is B, and this student name is C, okay. Now this is student, right, who's A, right, so what he does it, right, so in his book, right, in the book, right, you have he has, say, some 100 examples and questions, right. So what he does is, right, he learns every question by heart and he also learns the answers by heart, okay. So when the teacher is teaching in classroom, right, when teacher is teaching in classroom, right, and the teacher teaches 100 questions there, right, 100 questions, he learns them, right, by heart, right. And right, in the classroom, which means that when the training is happening, when the training is being performed, this guy learns everything. And if out of these 100 questions, if anything comes in the examination, okay, in the examination, right, so when testing the knowledge, when testing the knowledge, right, testing the knowledge, if he is testing the knowledge, right, if all the questions are coming out from these 100 questions, he is able to respond pretty well and score 99% there. Have you seen these kind of students? Yes. Now the second kind of questions we have, right, second kind of people we have, right, second question, right, what are these students, right. So we have the students over here, right, right, who when you're teaching in the classroom, right, when you are training, when you are getting the training, right, in this classroom, right, this student, right, out of 100 he understand only 60 questions or 50 questions, right, not even 60, right, he understands some 50 to 60 questions, right, 50 to 60 questions out of 100, okay. And when you test the knowledge, right, when you do the testing knowledge in the examination, right, he is able to perform poorly, right, because he understood only 50 to 60%, he cannot go beyond this. So he get the score of 50 to 60 over there, right, or maybe he can perform even more poorly, right. There is another student over here. So when training is happening in the classroom, right, he understand everything in a precise manner. So he doesn't understand the 100 question, he understand the concept behind it, okay. He understand the concept behind it. So he is not able to score exactly 100%, he's understanding all the 100 questions, right, or maybe he is not able to understand 100 questions. So out of 100 questions he is able to understand, say, 85%, 85 out of 100, right. But when testing is happening, right, testing is happening, right, he is able to score somewhere around 80 out of 100. This student is not the topper but able to understand the topic in such a way that it can do certain things, going forward. Now what is why I'm telling you all of these things? Because these people, right, if you just pick up a line over here about all these people, right, these people, right, this guy is a topper, this guy is topper, right, this guy is not very topper, it's a very bad student, right, in terms of marks only. I'm not saying anything else, I'm saying in terms of marks, right. And this guy is a general student, right, general, right, he is able to understand the concept, right, concept, and can do certain things over here, right. So now we have three kind of students, okay. These kind of students, when they go for IIT examinations, or they go for, say, some examinations where the testing of real knowledge happens, they miserably fail because they never understood the concept, right. So when they go to competitive examination, right? I'll say competitive examination, right? Or real time, when they've been asked to do real time over here, they they generally do not pass, right? They get only 60% of accuracy, right? Or they never get the very good percentage over there. But what these people, they were neither good in training nor in testing environment, so they are very bad students and they perform even poorer, right? So when they go to real time scenarios, they miserably fail, right? And they may be able to score somewhere between 40% to 60. These numbers are indicative, okay, not the exact numbers, right? 40 to 60%, so they are not able to clear. Whereas these people who were generic, right, and they were not able to um, you know they were not able to score well in the bookish examination, when they go to real time scenario, they are able to score 80%, right, what they have done in the testing environment. Do we understand the distinction between all of these examinations or all of these student types, people? Now, what exactly is happening over here, right? I have shown you three kind of students, right? Let's look at the same thing over here, right? Let's say we have, right, some kids over here, and I'm gonna draw the same patterns over here. I'm gonna pick up a pattern like this. I'm saying, suppose these are my students, right? these are my this is my training data, okay, and this is going to be my testing data, right? Because training data and testing data are all same, right? They are just very much mingled up properly, right? Let me just copy this over here, something like this. Confirm and confirm. Now I want you to understand this, right? What happens when you ask this guy, because now here I want to notify this to you, right? If you have this right here, this is my training data and this is my testing data, okay? I'll just specify over here, this is my training data, training, and this is my testing data, okay? Green is testing. So when these kids, right, who are learning the way exam is being performed, what they do is they follow a certain path, something like this, something like this, right? They learned too much, they were not able to generalize, they are not able to understand the implementation of it. And what happens because of that, they are far away from the testing examples. If this is your line of prediction, right, look at the error over here. You see the error? Do you see that the error will always be increasing for majority of the points, right? Error will be always increase, yes, no, maybe. Do you understand where I'm coming from? They learn the data too much, and because of that they are much away from the testing. So they perform in training data, they are able to score very high accuracy, very high accuracy, okay, very high accuracy. But in testing data they get very low accuracy, which means whatever they have been given to them, right, to learn, they are able to learn it too much, right? But when it comes to generalization of the problem or understanding the implementation of the problem, they are not able to understand that at all. The second kind of people, right, they are completely out of the track, okay? So what they do is, this is your training data and they are not at all aligned with the training data at all, right? So they in training accuracy is low, and in testing also accuracy is very low, right? However, there are some kids who understand the balance between learning, right, and real time thing. They are able to generalize the data well, and if they are able to generalize the data well, though in training environment their accuracy becomes 80%, but in testing environment their accuracy still doesn't lose very much, right? 78% or something. These people, when they, these kind of model or people, when they go into the real time scenarios, they are able to perform very much closer to the actual value. And this is what we thrive for. This is what we thrive for. Do you understand where I'm coming from, everyone? Do you understand where I'm coming from? Now here, these kind of students, right? How do I call them, or what do I call them? These are the people who are overfitted. Overfitted. Okay. These are the people who are underfitted. Underfitted. Right? And these are the people who are just right. Just right, or you can say balanced. Balanced. Okay. Would you be able to recall this? Would you be able to recall this, people? Tell me, right? If somebody will tell you what is overfitted, would you be able to recall? The training high, very accurate, very high accuracy, testing very low. Training very low, testing very low, underfitted, right? And just right or balanced people are who are able to generalize the data. Would you be able to recall this? All right. Now, when we say decision tree iteration number, now I'll just call this as iteration number 2, and I want to show you, right, what underfitted and overfitted means. Okay. Now, what am I going to do right now is I'm going to create a function over here, right? And this, I've already created this function, right? I've already created this function. So I have this function over here, and what this function is doing, it's actually picking up the model name, right? And after picking up the model name, it is calculating the accuracy results, and it is picking up the training results and all, right? And this is also creating the confusion matrix for the data, right? This is going to be my function which I'm trying to predict over here. Let's say so I'll just remove this, right, command over here. Let's see. So I don't want this confusion matrix to appear. I want this to be appear over here. This is going to be my score, right? This is my function, and what this function is doing, it's actually picking up the model, creating the x underscore train and y underscore train model and everything, and it is calculating the accuracy score and sharing the results. Okay. So what I'm going to do, I'm going to call this function over here called print score, and I pass on my model name, right? What is my model name? My model name is tree. Okay. And I say I want to pick up x underscore train data, I want to pick up y underscore train data, and I want to pick up x underscore test, and I want to pick up y underscore test over here. This is small y underscore test over here, and I can say train is equals to, I have to define, right, basically what I need to define, I need to define train is equals to true or not. So if train is equals to true, it is going to show you the accuracy for training data, which I have defined over here in the function. And if training is equals to false, right, if this is going to show me the accuracy for my testing data. Okay. Now I want you to look at this. Okay, look at this value over here. Now if you look at this, in training data, when I'm testing the data from training, right, instead of passing on testing data for prediction, I'm passing on training data itself. How much accuracy I'm able to get? Approximately 100%, right? You need to tell me what kind of model this is, and if you check for the test results, the test accuracy is 79%. What kind of model we have over here, people? What kind of model we are able to see? Overfitted. Amazing, right? So we can see this is overfitted model, right? Which means that it has learned too much. It has learned too much values from the training data, but it is not able to perform very good on testing results. Now when this model will be given, or if you put this model into production, right, what will happen? This accuracy will further drop to 72% and 70% or something, which has not been considered as a very good accuracy, to be honest, right? So there is no standard for it. but there, as compared to what it was getting in training and testing, this is not a very good accuracy, okay, which you can see over here. Now I show you something very, very interesting, right? Can I apply logistic regression in this data, right? I'm just thinking, can I apply logistic regression in this data and check if logistic regression can be applied? Like, let's see, can we apply logistic regression? The idea is not to test the logistic regression. The idea is that whether every machine learning model is giving me the same results, logistic regression in this model. Can we try this out, right? So let's do this. So we will import my model. So I'll say, first of all, import the model. The second value is instantiate the model. Right? The third value is fit the model, and then fourth is, right, predict from the model, right? That's what we are supposed to do. So importing the model means we can say from sklearn, right, dot linear model, right, import, right, logistic regression, right? Instantiating the model means I'm just picking up log reg, short form of logistic regression, is equals to logistic regression, right? I'm instantiating my model over here. Fitting the model means I'll say model dot fit, right, y underscore, sorry, this will be x underscore test comma y underscore test, right? Y underscore, we will pick up x underscore train here, right? X underscore train over here, my data, and I'll pick up y underscore train over here, right? And last part is we will do the prediction of this model. So we'll say y underscore predicted value, right, or for logistic regression is equals to, we will pick up log reg, right, and dot predict, right, and we can say pick up x underscore test. Okay, this is going to be my prediction, right? Sorry, model is log reg, sorry, my bad, right, log reg. So you can see that it is able to fit the model over here. Now if you want to test the same thing, right, testing the function, right, we can say testing the function for logistic regression, right? We want to see if logistic regression is also overfitted, right? So instead of tree, I will be picking up log reg, right? Rest everything will be same. And instead of here we wanted to calculate the predicted value as well, right? It will just do that all the time, right? Let's do this. Now look at this. What is the accuracy of the training? 84 point, or you can say almost 85%. Okay, what is the accuracy for testing? 82%, right? What kind of model we have over here? What kind of just right model? It's a balanced model, right? There's not much difference between training and testing, right? So you can see that logistic regression is not overfitted, but people, decision tree is overfitted, right? However, if I would have performed the same thing in logistic regression, I have to do a lot of EDA, but in decision tree I don't need to do a lot of EDA over here. So what am I going to do is I'm going to solve this problem, right? That you know, what decision tree is giving me, right? I'm going to solve that problem, and I will do that tomorrow, right? Tomorrow we'll be picking up one more machine learning algorithm, and rest of all the topics, I guess tomorrow is the last day for learning. Yeah, everyone, we will be picking up this model tomorrow, right? And tomorrow we will be executing, and we'll see how we can resolve this problem, right, over here. All right, I hope people, right, you've enjoyed this learning. Let me know in case you have any questions.